Yes, good morning. So, in the last lecture, we have covered the part of the design strength of the tension member and all the three design strength of the tension member we have seen. So today we will see the examples or examples based on the load carrying capacity of the tension member, and for that we will see first procedure and we will move towards the solving the examples. Okay, so our topic name is a tension member. So type 1 type 1, that is the load carrying capacity of tension member. Load carrying capacity of tension member. Okay, so we will see the procedure first and we will solve the example. So procedure. So type 1, what we have to calculate? Type 1. Sorry, step 1. Sorry. Step 1. In this step 1, we have to calculate write down everyone, calculate diameter of bolt hole. Calculate diameter of bolt hole, that is nothing but DH. So as per the earlier procedure, we can calculate the DH is equal to D naught plus 1, or DH is equal to D naught plus 2, or DH is equal to D naught plus 3. So this is one. In this way we can calculate. This is for D naught plus 1 for D naught plus 1. When we will use D naught plus 1, D naught plus 2?
D naught less than 1
D naught less than equal to 14 mm.
Diameter of bolt less than or equal to 14 mm. Then diameter of bolt D naught is
16 to 24.
Greater than 16 mm or equal to 16 mm to 24 mm. Correct? And here D naught greater
above
than
24
mm. So in this way we can calculate. So step 2. Step 2, calculate net area of plate or angle section. Calculate net area of plate or angle section. net area of plate or angle section. So we have seen how to calculate net area for plate or net area for angle section, that we have seen in detail in the Eisenstein calculation. So net area for plate. For plate we will see. So An is equal to, actually we have seen the rupture design strain due to rupture of critical section. In that, the net area for plate is there. One formula we have seen for plate, one formula we have seen for angle. So in the plate formula there is a An is there. So An we can calculate by using the formula B minus N into DH into T. And here N is equal to number of bolts. So that we have seen in detail. Then how to calculate net area for angle? For angle. For angle we have to calculate net area for two areas we have to calculate, that is A and C. So A and C we can calculate D minus N into DH minus T by 2 into T. In this way we can calculate A and C. And AGO second area we have to calculate, that is W minus T by 2 into T. Okay. So these are the two areas, net areas and gross areas we have to calculate in the formula of rupture of critical section, that is TDN, that we can calculate. And one more formula is there, AN. If this is for beta formula and this is for alpha, जेव्हा आपण अल्फाचा फॉर्म्युला यूज करणार तेव्हा AN असतो, जेव्हा बीटाचा फॉर्म्युला यूज करतो तेव्हा ANC ने AG असतो. So here AG minus N into DH, AG minus N into DH कसं होतं, बरोबर आहे ना, into T असंच होता का? Please verify this formula.
N नाही सर तिथं.
AG minus N into DH नाही का?
DH आहे फक्त सर.
DH into T आहे का?
Yes sir, DH लाच multiply T आहे, whole bracket ला नाही.
Just a minute, I will check. And then we will go ahead. Yes, there N is there. Please correct this. N into DH is there. And actually, this bracket, please correct the formula. This bracket is only for this here, AG minus N into DH into T, like this. AG minus in bracket N into DH into T. Okay, so this is for ANC and AGO for beta and AN is for alpha. Okay, so this is your second step. Okay. So step 3. Just wait. My health issue is there. Please give me 2 minutes. Wait for 2 minutes. Sorry for disturbance. Okay, so step 3 will be design strength, or we can say right, calculate design strength, due to yielding of gross section. It means as we have seen 3 design strength. So out of this first design strength, we have to calculate, that is TDG is equal to AG into Fy divided by gamma m. So this is the first design strength. After first 2 steps, we have to calculate. Then step 4. Calculate design strength. Due to rupture of critical section. Or net section. So as we have discussed these 3 design strength in detail, so I'm writing just here formulas, not writing any notations or any meanings of this particular notations, because we have seen in detail. Then design strength due to rupture of critical section. So again, we have seen for plate, the different formula is there, that is TDN is equal to for plate 0.9 AN into FU divided by gamma M1. Correct? This formula we have seen. And for angle, again TDN is equal to, we have seen 2 formulas. TDN is equal to 0.9 ANC into FU divided by gamma M1 plus beta into AU into Fy divided by gamma M0. So this formula we have seen. And one more formula we have seen for the angle, that is TDN is equal to alpha AN into FU divided by gamma M1. I think correct, this formula. Second.
Yes, sir, correct.
Okay, so these 2 formulas we have seen. So when we can use the alpha formula and when we use the beta formula, if number of bolts are given, or for the design we can use this formula. When we will use these formulas, always for finding the load carrying capacity. For finding load carrying capacity, always we can use this formula, load carrying capacity. This formula. So now आपण सध्या प्रोसिजर पाहतोय ती लोड कॅरिंग कॅपॅसिटीची, त्यामुळे आपण बीटाचाच फॉर्म्युला यूज करणार आहे. बट अल्फा फॉर्म्युला व्हेन वी यूज इफ number of bolts are given, at that time we will use this formula. Are you getting? Or design of tension member. It means in second type. Now we see here, we can see here the type 1, that is load carrying capacity, and type 2 is for design of tension member. So in the design of tension member, always we will use this formula, alpha formula, and now in this particular type we will use beta formula. So these two formulas also we have seen in details also. Okay. Okay, so next step 5. Step 5 is calculate design strength, which is remaining design strength. Design strength due to which is remain third,
block shear.
block shear. Okay, so in the block shear also two formulas are there, TDB1 and TDB2. So whatever is less will be the design strength. So TDB1, formula for TDB1 is AVG into Fy divided by under root of 3 gamma m naught plus 0.9 ATN into Fu divided by gamma m. This is first formula. First design strength due to block shear, and second design strength due to block shear is 0.9 AVN into Fu under root of 3 gamma m naught plus, sorry, gamma m1, sorry, gamma m1 plus ATG into Fy divided by gamma m naught. So these are the two formulas for the block shear. And last step, step number 6. So in that is step 5, the minimum, write down sentence, minimum value of TDB1 and TDB2 is the design strength, is the design strength of block shear, is the design strength of block shear. And step 6 म्हणजे या दोन्हीतली मिनिमम असेल ती ब्लॉक शियरची डिझाईन स्ट्रेंथ असेल. And last is the design strength of tension member. Design strength of tension member so write down the least value, the least value of the least value of TDG, TDN and TDB is the design strength of tension member, is the design strength of tension member. It means what? Out of design strength due to yielding of cross section, design strength due to rupture of critical section, and design strength due to block shear, out of these three, whichever is the less or whichever is the least, that will be the final design strength of the tension member. Got it, everyone? Similarly, we have seen in bolted connection, strain due to bearing, strain due to shearing, and strain due to tension. Out of this minimum of these three will be design strength of bolt. Similarly, how to know design strength of the tension member? The design strength of the tension member, it will be the minimum of this TDG, TDN, and TDP. Got it?
Yes, sir.
Okay. So this is the procedure. So we will see the examples of the basis of this type 1. So example number 1. Example number 1. Write down, everyone. Write down. Two plates 180 mm by 20 mm. Two plates 180 mm by 20 mm are connected in a lap joint connected in a lap joint using bolts of 20 mm diameter as shown in figure. Full stop. Determine the strength of plate. Determine the strength of plate in tension. Strength of plate in tension. Full stop. Take Fy is equal to 250 Newton per mm square and Fu is equal to 410 Newton per mm square. Okay, so this is the problem statement they have given. Two plates they have connected by using the lap joint by using the bolts of 20 mm diameter, and we have to find the or determine the strength of the plate in tension. So how much strength they can carry in tension. So it means these plates are under tension and we have to calculate the tensile strengths of that particular plates. Okay, so they have given this sketch. So I will draw the sketch first. How two plates are connected by the lap joint. Okay, so this way two plates are overlapped. Also, they have given So this way they have given the sketch. It means they have given pitch distance, edge distance also here. Okay. It means 6 bolt they have given. This 6 bolt, through this 6 bolt, 2 plates they have connected, and I think the plate, this is the length of plate. This is the, I think, 20 mm width of plate. Okay, so now we will solve this example. Okay, so we will go step by step. So step 1, if you follow the procedure, then there is no difficulty to solve this example. So but you have to go step by step. So what is first step? So step 1 is a calculate diameter of bolt hole. Diameter of bolt. So DH is equal to. So DH is equal to. Which formula we have to use here now?
D0 plus 2.
So D naught plus 2, because the 20 mm diameter is given. It will be the range from 16 mm to 24 mm. So D naught plus 2. So D naught is a 20 plus 2 is equal to 22 mm is the diameter of bolt hole. Okay, so this is the step 1. Now move towards the step 2. Step 2, calculate net area of plate. So here this net area per plate we are using in the formula of rupture of critical section. Whatever in the step 5 or 4 we have used the formula, that is TD, and that is the rupture of critical section. So there we have to requirement of the net area. So this is the plate. So for this plate, which net area required, that is very important. So if we solve the example, you will become expert. Okay, so now plate, these are the plates. So in the plate, which formula we have to use? AN. So for the plate, what is the formula? B minus B minus N into DH into T. So here B is 180 minus, now N, how much N here?
6.
6 into DH, 22 into thickness of plate. Actually
20.
no, actually 20 by this 180 by thickness they have given 20 mm. We have used here width. So please erase this. This is not this is your 20 mm. Okay. So here into 20. So how much area in mm square?
960.
960. Correct. 960 mm square is the net area of plate by deducting the holes. Okay. So everyone got it this step? Okay, we'll move next. Next step, step number 3. So what is step number 3? Calculate design strength due to yielding of cross section. Yielding of cross section. So again, we have to use that formula, that is TDG is equal to, this is the for yielding of cross section. Design strength, D is for design, T is the for tension, and G is the for gross. So design strength due to yielding of cross section. So what is formula? AG into Fy divided by gamma m naught. So AG here, what is AG? Gross area of plate. AG is the gross area of plate. How we can calculate gross area? Okay. So we are at step 3, that is design strength due to yielding of cross section. Yielding of cross section. Yielding of cross section. Okay. So now that formula is TDG is equal to AG into Fy divided by gamma m naught. So now how to calculate gross area? The area of any section, how we can calculate if the geometry of section is known. Here the size of plate is given. So simply you can calculate the gross area. So 180 by 20 is the gross area, correct? 180 by 20 is the gross area, correct? So 180 by 20 into Fy is given 250 divided by gamma m naught is how much?
1.1.
1.1. So now you can calculate this. 1.1.
818.18 kilonewton.
818.18
kilonewton.
Okay, good. This is the your strength due to yielding of cross section. It means that much load can carry due for the yielding. When the member will fail, these plates will fail at this load, this much load will be carried at that time, that plates will fail. आठशे 18 लोड आल्यानंतर त्या तुमच्या प्लेट यील्डिंग मध्ये फेल. ओके. सो नेक्स्ट स्टेप 4. Again Step 4 is calculate design strength due to rupture of critical section. That is, the formula is TDL. For plate, now we have to use here. So use the formula. Again, wait for 2 minutes. I will back in within 2 minutes. Okay, again, sorry for disturbance. Okay, so design strain due to rupture of critical section, TDN. So for the plate, there is a formula. Have you written? Anyone of solve it? 0.9 AN into FU divided by gamma M1. So 0.9 AN we have calculated where in step number 2 we have calculated
960 mm square.
960 mm square into FU
410.
410 divided by gamma M1 is a 1.25. So you can calculate
283.392 kilonewton.
280
83.
283.392 kilonewton. So this is the design strength due to rupture of critical section. Now, one more thing is there. The plates are not fail due to block shear. See, the block shear failure will be for the angle only. Generally, plates are not failed due to block shear failure. So there is no necessity to calculate the block shear failure for plate. There is no necessary for calculation of block shear failure for plate. So here we will calculate the design strength out of these two. So out of these two, whichever minimum is the design strength of the that tension member. येते का लक्षात? ब्लॉक शेअर फेल्युअर प्लेटला होत नाही ते ज्याची थिकनेस कमी असते. ब्लॉक शेअर फेल्युअर कधी होतं? ज्या सेक्शनची थिकनेस कमी आहे. आता अँगल्स किती एमएम चे असतात? 6 एमएम ची, 8 एमएम ची. ह्या ठिकाणी प्लेटची थिकनेस किती आहे हो?
20 mm.
20 एमएम. सो प्लेटची थिकनेस जास्त आहे, इथं कधीच ब्लॉक शेअर फेल्युअर होणार नाही. आपण जर उगीच कॅल्क्युलेट करत बसलो तर आपला वेस्ट ऑफ टाइम जातो. ब्लॉक शेअर फेल्युअरची स्ट्रेंथ या ठिकाणी तुम्हाला 1000च्या पुढे मिळेल. म्हणजे 1000 किलोन्यूटन इतकी ब्लॉक स्ट्रेंथची डिझाईन स्ट्रेंथ मिळेल तुम्हाला. मग आपण प्लेटला कॅल्क्युलेट करत बसण्याचा वेळ घालवण्यापेक्षा आपण डायरेक्टली we can jump on the second example. Okay, so here so always do not calculate block shear strength for the plate. If angle section is there or any channel section is there, there may be a thickness is less. For channel section, flanger section, 8 mm, 10 mm thickness are there. So where less thickness of section is there, there may be chances of block failure. लक्षात येते का कशामुळे ब्लॉक फेल्युअर होत आहे? थिकनेस कमी असेल तर तो त्या बोल्ट त्या प्लेटला किंवा त्या अँगलला किंवा त्या चॅनलला काय करणार आहे? तो तोडून टाकणार आहे बोल्ट. थिकनेस कमी असेल तर. सो दॅट ब्लॉक शेअर फेल्युअर विल ऑकर वेअर द थिकनेस ऑफ सेक्शन इज लेस. So here thickness of plates is 20 mm. So greater thickness is there. So there may be no chance of block shear failure. So त्याच्यामुळे आपण याच्यामध्ये कॅल्क्युलेट करत नाही. So we will take the design strength next step as a directly design strength of the tension member. So step 5 is design strength of tension member. So out of these two, last TDG and TDN. So the least value of TDG and TDN is design strength of tension member. Design strength of tension member. Okay, so whichever is less,
TDN.
TDN.
So TDN is equal to 283 point how much?
392.
2 kilonewton is the design strength. It means what? Who will tell me? Design strength. It means now what? There are 3 chance of failure in tension member. Due to yielding of gross section, due to rupture of critical section or net section, and due to block shear. So here the less strength is which? TDN.
Rupture of critical section.
So it means what will happen? These bolts can rupture or punch to this particular plate, and due to this such cracks will happen. Are you getting? So this is the major failure in this particular plate. Got it? Rupture. Okay. Okay, so now we will this is this first example. Okay, so now we will see the example number 2. Example number 2. Okay, so write down problem statement. A single a single angle ISA 90 by 60 by 8 Indian standard angle 90 by 60 by 8 at 6.8 kg per meter. At 6.8 kg per meter, it means what? 1 मीटर जर 90 बाय 60 बाय 8 चा जर आपण अँगल घेतला तर त्याचं 1 मीटरचं वेट किती असेल 6.8 kg. So in the market the sections are available in this type. आपण म्हणतो मला आय सेक्शन चॅनल सेक्शन स्टील खरेदी करायचं आहे. We are thinking or we are talking about we have to purchase steel. So steel is available in market in this form. Whichever section is there, that section per meter how much kg weight is there. एका मीटरला किती केजी आहे त्याच्यावरून तुम्ही 8 मीटरचा 7 मीटरचा घेताय की 10 मीटरचा सेक्शन घेताय as per your requirement. मग suppose 10 meter you have purchased. So per kg weight is how much? 6.8. So 10 into 6.8, that is the 68. 68. So what is 68 what?
kg weight.
Into we have to multiply by rate rupees. If again 60 rupees. So then 68 into 60, how much?
4080.
4080. So एवढ्या रुपयाला हा 10 मीटरचा तुम्हाला हा सेक्शन मार्केट मधून मिळेल जर 60 रुपये त्याचा पर मीटर पर केजी रेट असेल तर. एका किलोला 60 रुपये रेट असेल तर 68 केजीचं 60 रुपीजनं 4800 म्हणजे तो 10 मीटरचा पीस तुम्हाला कितीला मिळणार हो मग. So in this way, as we are civil engineer purchasing the steel from the market. Got it everyone? This is the not a part of actually our design. This is the part of the estimate, how to calculate estimate of any project. So that comes under the estimate, that will be the that part you will in the final year engineering. So those who are direct second year student, they may know estimate and costing subject. But those who are regular, they will know how to calculate the quantities of the structure. आपण कितीही स्टोरेज बिल्डिंग डिझाईन करत असू द्या, प्लॅनिंग करत असू द्या, ती बिल्डिंग ही त्याचं एस्टिमेट आपण करू शकतो किती खर्च येईल. Are you getting? So that you will learn in the final year engineering. Okay, we will write the or we will stop here. This problem we will solve in the next lecture because I think as per our timetable your time is over and you will join for the next class at 12:30. So this problem we will solve at or we will see in the next lecture. Okay, so we will stop here. So wait, I will take attendance. and then we will close.